question, trigonometry question. Very important, guys, but I'm going to go through it slowly so we can understand what we're talking about. Okay, so let's take a look. It says, prove the identity. Guys, the moment you get a prove, you're going to have something on the left-hand side is equal to something on the right-hand side. You pick a side to work with and you manipulate it to try and get it to look like the other side. So I am going to pick the left-hand side. A lot of your teachers, guys, will say pick the side that has more stuff on it. So my left-hand side, 1 minus tan squared of theta all over 1 plus tan squared of theta. Okay, and obviously we're trying to get it to look like cos squared of theta. So what I'm going to do is I'm first going to change tan to sine. But guys, remember, if I have a squared attached to my tan, the sine over cos, remember, tan is equal to sine over cos. If I have a square attached to that tan, both of those need to get a square as well. So 1 minus sine squared theta all over cos squared theta is just the numerator. We still have to address the denominator. So what I'm going to do is I'm going to split that tan as well. 1 plus sine squared theta over cos squared theta. Okay. So at this point, you should notice this is a whole fraction. We need to deal with that fraction first. I'm going to leave the 1 for now. We will get back to that. So if I carry on manipulating, let me just move this question out of the way because I'm going to need a lot more space. Question. Down you go. Okay. So if I carry on manipulating this situation, I have 1 minus. The numerator can stay the same for now. And in the denominator, guys, I have 1 plus sine squared of theta over cos squared of theta. So if I want to add that 1 to this whole fraction, we find an LCD, okay, which is cos squared of theta. So to get over the LCD, I multiply by it. So 1 multiplied by cos squared theta is cos squared theta plus sine squared theta all over cos squared theta becomes our new denominator. Okay, so guys, remember that this whole situation became that whole denominator. Okay, work with everything slowly and separately so you understand what you're talking about. So now let's take a look at this. In my numerator, I have sine squared theta over cos squared theta. So that we can leave for now. That is pretty much as expanded as is possible. Then in the denominator, guys, you should know that this is an identity. Cos squared of an angle plus sine squared of the same angle is equal to 1. So we have 1 over cos squared of theta in that denominator. Okay, so now you guys should know immediately from, I don't even know when you cover this, it's somewhere in primary school, when you are dealing with dividing by fractions, we tip in times, okay? The rule comes from the idea of reciprocals. They multiply to give you 1. So I have 1 fraction, sine squared theta over cos squared of theta, times, we tip this whole fraction upside down, cos squared theta over 1. Okay, so now if we have a look-see, cos squared theta will divide into itself over there and divide into itself over there. So we're going to get 1 minus sine squared of theta all over 1. This denominator can just stay as 1. And guys, the identity, if I have cos squared of theta plus sine squared of theta equals 1, then I know that cos squared of theta is equal to 1 minus sine squared of theta. And what do we have over here? 1 minus sine squared of theta. So we get cos squared of theta. And that is equal to our right-hand side. Remember, we had to prove that the left-hand side, which is what we've been working with, is equal to the right-hand side. So guys, with your trig identities, you need to remember, if it says prove the identity, prove an identity, if those form part of your questions, take a side, often the most complicated side, it has all the stuff in it, expand it, take that one side, say I'm working with the left-hand side, expand it, break it down into its different identities and parts and things, and manipulate it to get it look like the other side, okay? If you can manipulate one side to look like the other side, you have proven that that identity exists, okay? So, second part of the question says, use your answer, guys. Easy peasy. That means that instead of using that whole massive identity, we can use this over here. So if you look over here, we had very generalized form. In this identity that we had to prove, they said specifically of theta. The angle we were working with is of theta. So now if you look down here at the second part of the question, instead of using theta, they've now said rather a half x. So now you need to prove that identity. So if you look here, we have the same angle, half x, half x. So we know that the identity that we've just proven stands. So I know that this whole thing is equal to cos squared of the angle we are dealing with. Okay, that is what we proved in the first part of the question. So we now need to find the general solution. If we know that this is equal to a quarter, we know that we need to solve for our cos solutions. Okay, guys, when you get a general solution, you need to remember with sine and cos, you are always going to get two different answers. Because sine and cos are positive both in the first quadrant, remember your cos diagram, the first quadrant, all of our ratios are positive. And then sine and cos are positive in two other quadrants. So you need to sort those out. Okay, remember, you need to address both quadrants. So let's take a look at this. If we manipulate this, we're trying to get into the form of cos of x. So the first thing we do is square root it. So if we square root, we get cos of a half x is equal to the square root of a quarter. Remember, guys, every positive square has a positive and negative square root. If I square a half, I get a quarter. Okay, so we know that cos of a half x is equal to a half, or, get some space, or cos of a half x is equal to negative a half. Okay, so now what you can do is you go and find your reference angle. If I say second function cos of positive a half, I'm going to get 60. So I know that cos of a half x is equal to 60 degrees. And remember, the cosine graph, because it oscillates the way it does, starts at 0 and 1, and it does that. This point over here coincides with that point. It repeats every 360 degrees. Element of the integers. Remember, this k is an element of the integers. So, then we move on. Cos of a half x is equal to, we go back and we say second function cos of negative a half. And we get 120 degrees plus k360. And k is also an element of the integers over here. Okay, so those are our two solutions from our two different answers. Now, guys, I hope you've noticed that we're working with a half x. If we want to get to x, we have to times everything by 2. So cos of x is equal to 120 degrees plus, guys, very important, the whole equation must be multiplied by 2. So we even multiply that period, that k360 by 2, and we get k720. Same for this solution down here. Cos of x is equal to 240 degrees plus k360. And k is an element of the integers. Okay. Whoops, not even 360. I've just reiterated that and I made the mistake. Multiply everything by 2. Okay. But now, guys, remember, that is only one solution in these areas. Like I said to you, if we look at our cos diagram, C, A, S, and T, cos is positive in the first quadrant and the fourth quadrant. The first quadrant is your reference angle. The fourth quadrant is 360 minus the ref angle. So You need to go back and deal with that fourth quadrant. So over here, cos of x is equal to 360 minus 120 degrees plus k720, which means that cos of x is equal to 240 degrees plus k720. And you go and do the same thing over here. Cos of x is equal to 360 degrees minus 240 degrees plus k720, which means that cos of x is equal to 120 degrees plus k720. Because you've stated that it is an element of the integers, that follows suit. You don't need to keep rewriting it every time. Okay, so guys, when you get a general solution, like I said, first thing you need to do is find your ratio of the angle is equal to a number. Once you do that, you can use arc cos, arc tan, arc sine. That's what you do when you shift cos on your calculator, okay? You get cos to the -1. That's not the inverse of cos, that is arc cos, okay? Very important. Then you go and you find your reference angle and you sort them out. But remember, sine and cos, they repeat every 360 degrees. Tan, every 180 degrees. Okay, remember that repetition of their periods. Then you need to double check with cos if you've addressed the two quadrants that it is positive in. Positive in the first quadrant and the fourth. If it is a sine ratio, positive in the first and the second, 180 minus. Okay, very important, guys. If you get a cos squared or a sine squared, you are going to get 4 general solutions, okay? Because squared, you know, your quadratic formulae, you're going to get 2 answers. Same thing with your cos squared and your sine squared. You're going to get 2 answers, and they need to be addressed in their 2 quadrants, so you're going to get 4. Remember, very, very, very important. Okay.